So we're just going to review how you get the GCF of different terms, right? So here we have 16x, y, z, x, y squared, z squared, 72x, y, z cubed. So the way you come up with the GCF is first you do the prime factorization of 16 and you do the prime factorization of 72. We will review how to do that. But then you write all of your variables without any exponents. Once you've done that, and again, I will review how to do prime factorization, you circle all the pairs that you can. Now, I can't circle 2 and 3 or 2 and 3, so I don't. But I end up with a 2 times 2 times 2 times x times y times z times z. So if I multiply that out, I get 8xyz squared. And that would be the GCF. Okay, now notice when you're getting the GCF of variables, it is always the lowest degree of each variable. So in other words, x and x, it's only x to the first. Whoops, I didn't mean to erase that. Okay, x to the first, this is x to the first. This is y squared, but this is only a y. So you take the lowest degree, which is y. This is z squared, this is z cubed, so you take the lowest degree, which is z squared. So for variables, you always take the lowest exponent. Okay, so now let's go over a factor tree to get the prime factorization. So if I was to do the prime factorization of 16, I always start with a 2. Right? If I know it's divisible by 2, I start with a 2. If it's divisible by 3, I start with a 3. I start with small prime factors. So this is 2 times 8. This is prime. I circle it. This is 2 times 4. This is prime. I circle it. This is 2 times 2. They're both prime. So the prime factorization of 16 is 2 times 2 times 2 times 2. So now 72. So I'll start with 2 and 36. I circle it. 2 and 18, I circle it. 2 and 9, circle it. And then 3 and 3. So the prime factorization is 2 times 2 times 2 times 3 times 3. Okay, now, to be honest with you, most of the GCFs we're going to be able to do, you're not going to have to go through that process. You're going to be able to do it in your head. So let's go down to number 9, and we're going to try to find the GCF of 15 and negative 45. So just ignore the negative and just say, what's the GCF of 15 and 45? Well, I know the greatest common factor between 15 and 45 is 15. I think most of you do, and you can do that in your head. But let's suppose you don't know, and let's do the prime factorization. So this would be 5 times 9, circle it, and this would be 3 times 3, circle it. This would be 5 times 3, circle them both. So now I line up 45, and I write 3 times 3 times 5. I write 15, and I write 3 times 5. I circle the pairs they have in common. This is 3 times 5, which is 15, which is how I got a GCF of 15. Okay, so let's do another one. Let's do number 12. Okay, now, okay, so let's do 49x. We'll do it here. Now 49x, I could do a factor tree. I don't need to. I know it's 7 times x. Okay. Now, I know 343x squared is going to be x times x. So I know as far as the variable goes, it's just going to be an x. Because remember, I told you it's the lowest power that you see. I see an x to the first, x squared. The lowest is x to the first. So I know it's going to be x to the first. Now, 343. Okay, I know 7 goes into 343. 7 goes into 34 4 times, and it goes into 63 9. So this ends up being 7 times 7. So 343x squared is 7 times 7 times 7 times x times x. So I circled the 7, the x. So the GCF is 49x. This GCF is 49x. And again, like I said, you probably could have done that in your head if you knew 7 cubed was 343. But if you don't, you could have figured it out. So let's do number 13. So 4a to the 7th b and 28ab. Well, first, let's do the variables. I know that it's going to be ab. How do I know that? This is the lowest degree. This is the lowest degree. So we don't even have to do that part. Now, 4 is 2 times 2. 28 is 2 times 14, which is times 2 times 7. So what they have in common is 2 and 2, which is 4. So this GCF would be 4AB. Okay, so again, I did want to go over this, but most of what you're going to do when you're finding the GCF is going to be stuff you can do in your head. So let's turn the page. And let's do prime factorization of, let's say, 8, 11, and 14. So 108, I'm going to first divide by 2 and get 54. Divide by 2 again and get 27. 27 divide by 3. Whoops, circled the wrong thing. And 3 here. So we end up having 2 times 2 times 3 times 3 times 3. So this is 2 times 2 times 3 times 3 times 3. Okay, so now stop the video and on your own do 11 and 14. And when you're done, start it up and see if you get the same answer as me. So 144, now I'm going to break my 2 rule because 144 we know is 12 times 12. We know 12 times 12 is 4 times 3 and 4 times 3. And that becomes 2 times 2 times 3 times 2 times 2 times 3. So this would be 2 times 2 times 2 times 2 times 3 times 3. Okay, and then 357. 3 plus 5 is 8 plus 7 is 15. 15 is divisible by 3, which means 3 goes in. And 3 goes in 1, 1, 9. And 1, 1, 9. 7 goes in. Now, if you always have to check for 7 and 11. Those tend to be numbers we don't know by heart. But 7 times 17. So this is 3 times 7 times 17. So always check 7 and 11, see if that works. Okay. Okay. So that's all we're going to do with this. So we're going to go ahead and stop the video.